Thank you for joining this 30-minute webinar. So this is the first webinar we're doing. So hopefully this goes well. I'm not used to not having interactivity, so I'm not even sure if people are receiving me well. Um, but since we only have 30 minutes, I'm not going to be taking any questions during the webinar. But my email address is up on the slide here. And I will share the email address again at the end. So feel free to send questions to my email and happy to engage on that. Um, I haven't done a webinar before, so if we end early, we'll just give the time back. We can't enable questions, complications with webinar software. But so um, this talk is about migrations, why they're so painful, why they're inevitable, and can we fundamentally change the physics of how they work? Can we change our mental models? So, who am I? I'm the co-founder or the founder and CEO of Matterbeam. I have been building systems and startups around data for 25 plus years now, which is kind of crazy to think about. I've worked on storage hardware, I've worked on product, databases, machine learning, AI stuff, early AI stuff, analytics, all of it connecting together with a certain perspective of how to really effectively use data and enable new uses of data. And that's the basis for Matterbeam. Um, so Going here, I saw this video that Matt Ranney gave. It was a talk he gave back in 2022. And this is the title, and I love it. Migration's the hardest actual problem in computer science. Um, he was presenting about DoorDash and how they had migrated stacks and databases and like three or four different ways they tried to do it. And it was a many year process, super painful. So I don't think the statement is hyperbole. I think it really is one of the hardest problems. There's jokes about the hardest problems in computer science. This actually may be it. These are the problems that vex us. Migrations are ugly. Um, there is absolutely no glory in it. The benefits are not always obvious. You end up with these years-long efforts to end up sometimes right where you started to replicate existing functionality. Just it works like the old system. Hooray. Um, Migrations tend to be like toothaches, right? You just ignore it until the pain is overwhelming, and then that crossover point is when like the business forces the migration, not when you choose it, and that's kind of like the worst possible time to do it. So it compounds, it makes it even worse. Migrations are inevitable. The only constant is change. Things change all the time. Companies scale, things evolve. You're gonna migrate. You're gonna migrate. The question isn't if, it's how many times and how painful is it gonna be. A rule of thumb I've seen throughout my career is when some metric or number in the business doubles, you usually have to rethink all of your systems and processes, right? Like double your employees or double your sales team or double your revenue or, you know, double seems to be a magic thing that once you double, you usually have to come back and reevaluate like what's not working anymore. So migrations are just really hard. It's a cliche, but it's rebuilding the plane while it's flying. Thanks Midjourney for this little video. You know they're they're not hard because they're big. They're hard because they force you to change something the business depends on while it's running at full speed. You can't turn these systems off. You can't freeze requirements. Half the dependencies you need were built like 5 years ago, maybe 10 years ago by people who aren't even at the company anymore. Every assumption, every corner case, every integration you discover along the way adds more uncertainty, and the business keeps moving, right? So you get new customers, requirements change, data shapes change. And so the target keeps shifting while you're aiming at it. So when we say migrations are really hard, it's not just technically complicated, it's just real world complicated because, the real world constraints make them risky and fragile and unpredictable. Um, it's one of the reasons why traditional approaches struggle because they tend to fight this reality. Um, I think we have a bit of a blind spot. One thing I've learned again in my career is that data outlives code and systems always. You always have the data from that first database you built. We tend to orient what we're doing around systems first, instead of data first. Like we treat migrations like they're software changes or rewrites, but most of the time the failure points are data. Data drift, data loss, data corruption, all of those things are the real risk factors in these kinds of migrations. Um, So we do have an existing playbook, right? When we do migrations, we've got the big bang migration, the phase migration, the parallel running multiple systems all at the same time. On paper, they kind of sound reasonable, but in reality, they all tend to break in the same ways. You know, uh, Big Bang, the dream is like the fast cutover, but that usually becomes like massive blast radius. Uh, Phased, again, there's like, well, let's not have the big massive blast radius. We'll do sort of small step iterations, but that usually becomes larger phases and motion rewrite with every kind of scope creep. So, and then the parallel option, is trying to be as safe as possible by running all of your systems in parallel, but then you end up having to duplicate all of your work and the drift is terrible, right? Because your systems never agree after that point. You end up in kind of like a reconciliation hell. And why are all these, failures is because the migration's a moving target. It's almost like the epitome of something like waterfall development in software. And you spend a lot of time with a big plan up front. You've got a big deliverable. You got a lot of hopes and prayers. And I think, from a software development standpoint, we learned to go in this sort of agile way, right? To build faster time to value, close iteration loops, and that sort of pattern creates success. So part of this is, can being data centric allow us to take more of the lessons from agile and bring them to migrations? Traditional migrations concentrate risk, right? They assume there's a finish line, the business can freeze, requirements don't shift, dependencies are known, everything can be predicted. And this is almost exactly waterfall thinking, right? You just do the big design up front and hope for the best. So with a Matterbeam approach or this sort of data-centric approach, the goal is to shift the risks dramatically, right? So change the risks of cutovers, change the risks of data drift, and allow things to roll back and replay and get a lot more comfort with the data itself that it's not going to get corrupted in these cases. There's still work to do in this model, but this is all about trying to eliminate some of the really dangerous and brittle parts to make those parts easier. So one of the big things again is migrations aren't really projects, right? We treat them like these monolithic one-time efforts, but I'm harping on this, the requirements and the business changes that whole time. And that's one of the things that makes it so hard. I've been part of some of these big migrations and there's lots of whiteboard sessions and planning sessions and, you know, requirement documents and 2-year timelines and none of it really takes into account that the change is constant throughout. Um, with migrations being orchestrated as kind of like these big monolithic projects, we tend to get very tight coupling. We get pipelines and systems and schemas that are wired together really tightly. And so you end up with these cases of this big monolithic thing trying to move through a process, and all upstream changes break downstream. Things like dual writes introduce race conditions. You end up with like backfills being incredibly brittle. It makes everything super high risk. this tight coupling and big project thinking itself just resists change. And sometimes that is actually reflected back out into the business, right? Where it becomes a drag on the business itself. Oh, we can't implement this new process because we're waiting for the migration. So we've been treating migrations like projects, big monolithic undertakings with start dates and Gantt charts and a false sense of stability, defining everything up front. And we're hoping that nothing we're doing, nothing moves while we're doing this surgery on the business. But reality again doesn't reflect this, right? Everything requirements evolve, teams ship new features, the business line changes, new customers get onboarded, systems get tweaked. So there's a big gap between the project plan and the real world, and it widens every day. Uh, so I think the answer is not a better project plan, and I think the answer is a better mental model and a better architecture, one that allows the migration to evolve with the business and not really fight against it. So instead of designing the perfect state up front and marching toward it, we need a way to migrate in smaller slices, validate continuously, adapt as we learn, change direction safely when the business needs it. And that's really the shift from a rigid project mindset to more of a reality, frankly, aligned, iterative, data centric approach. Uh, so, what does a migration look like today? Um, Frequently what you end up you have a big sometimes there's a bake off. We want to figure out what our end system is and start to design what our goal for our end desired state is. So that's the first step. Then usually there's okay, well, how does our existing system map to that end state, right, to the data that exists in that end state? And usually we there's a big project to figure out this mapping. Oh, it's customers in this system and it's users in this system or whatever, right? You have to figure out this mapping of both objects and schemas as well as processes. This one, two, and three is, like I said, a lot of these big whiteboard sessions and relationship documents and process documents and all of that. Um, and then, so the next step, once you've gotten your sort of mapping and your plan, you want to extract this data from a source, right? Usually this ends up some kind of bespoke process, right? You want to get data out. Sometimes tools have, dumps and reloads, but it's usually some kind of big batch thing that you have to do. And so you extract this data from the source, and then you load it up into your new test system. And then during that load, you want to sort of remap it, right? So you're going to do some kind of transformation. Again, this is kind of like a traditional ETL sort of thing. You want to do some transformations, you want to modify this data in some way to fit this new end state and end process model. Um, and then so this is all kind of done as this one big operation, right? And so what you end up with is test and testing and more testing, and you do this big blob move, and you keep testing. And as requirements change and everything changes, you end up going back up to the big one, two, three part of this diagram and creating even more requirements documents, running through this process again. But it's very big and very slow. So any change at any point disrupts the entire flow. So what are we proposing from a Matterbeam perspective? Ideally it's this idea of a more data-centric approach, right? One that is more based on keeping the data sane at all points. So you want to migrate. So let's walk through what a migration looks like when you stop treating it as like a big giant one-time project. Instead, treat it as an iterative data first evolution. So the goal is to make a process that's simple, safe, repeatable, that doesn't require, especially, this is the critical thing, doesn't require freezing the business, rewriting pipelines, and hoping and praying that everything works on the big bang cutover day. So for the first sort of step, we want to collect data from a source. We store this data, objects and tables in a flexible shape in it's basically a fact stream. At this step, you're not remodeling it, you're not transforming it, You're not doing anything with it yet. You're just capturing the facts as they exist today. And this process is also one that just keeps collecting continuously. So it's not a dump and reload, or it's not a stateful view. It's a continuous stream of facts coming out of the system that are being captured in the central view. This alone gives you something that you don't have today, right? A stable timeline of truth that isn't tied to the old system schema or performance limits. It's a thing that you can use and rely on that represents the changes that have been happening in that system. And in this case, you may not even know what your final system is yet. You know you want to migrate, but you don't even know what system yet. With this kind of a model, which I can get to later, you could actually try multiple systems. You could emit to two or three and do a bake off with real data and real users and see. So that's an interesting thing. So you have this data now continuously streaming into this centralized view, and you want to migrate onto a new system. So the thing you start off with is you identify a a small domain, something that you want to migrate. Not the whole ERP, not the whole CRM, not every workflow, just one object or one slice of the business. Um, it could be orders, or it could be invoices, or it could be opportunities, or whatever, right? You start with a slice because you're trying to limit the iteration scope, right? So you can do something safely. They're small, they're sort of testable. Because we have this basis of truth, they're reversible, and they're also easy to validate with like real business users. Why do we do this? Like the goal is much tighter iteration loops with value sooner. You want to get to a state where experimentation becomes fearless, right? And so you can spend time iterating on it until it works right. Uh, so you end up with sort of the fun part. You have this fact stream. You take the fact stream. Now you can late transform it and replay it into the new system. If the mapping is not quite right for that opportunity, fix it. Hit replay, rerun it again. The entire history flows again through, and now you have that view. Did the new system schema need to change or needs to be adjusted? Great. Tweak it, rerun it, replay it. Business logic changes mid-migration. Not a problem, right? Make that change, rewind, replay it to the target system. This is why I sort of harping on this waterfall agile thing, because this is where you start to get this idea of agile migration, what it might look like. Much shorter feedback loops, constant validation, much lower risk iteration. So once you're confident in your opportunities or your invoices or whatever it is that this domain is, you can shift read ownership over into this new system. So that means maybe you want to use some dashboarding tools in the new system. You want to use you want to use reporting. Anything that depends on those domain objects can now be pulled from the new system, not the old one. And this is pretty low risk move because the data is identical. It's flowing from the source through this thing, and you can always replay it back into the target system. And this is a great place again to get stakeholders involved to shorten that iteration loop. Hey, this report doesn't look right. This number doesn't look right. You have the whole history. You have the whole original source set. You can go back and look at it. Oh, I see. We didn't do this mapping right. Rewind, replay. Now you've got that view. Um, so you can iterate and build with the feedback from the business as soon as possible. Um, and again, from experience of building software, doing agile processes in software, this kind of fast iteration means you find the things way sooner that you're missing. You find the things that are just broken way faster. It means building the right thing much, much faster. If your right domains can be isolated, and this isn't always possible, but if they can be, and your team is ready, you can move the right ownership of those objects into the new system as well. Um, Now the new system becomes the system of record for that domain. Now, here's where, again, this new model starts to tweak our mental model a little bit. We can do this exact same process the other way. So we can collect data from system B now, and store it in this immutable fact stream and replay it back into A for the things that it is now the ownership. the owner of. So it lets you operate in this sort of hybrid mode where it's part old, part new, with clear ownership of who owns which right objects without doing any of the sort of classic dual right hacks or all the things that lead to this like incredibly painful data drift and other problems. Now, spoiler, we have on our roadmap also an idea, the ability to do full multi-master writes, where you wouldn't even have to isolate the write domains. And so, by using the central thing to track an immutable sync log, we don't have that ready yet, but just this alone is super powerful. So, the real power again in this, the magic is you can go back. You can always go back. This is really the most powerful part of this approach is that you never lose your inputs. Because everything is collected as immutable facts, you have the full timeline, you have the full history, you have the ability to recompute on demand, you have the ability to replay on demand, right? You can undo things that you did by replaying with slightly different views, right? You can kind of go forward or backward or sideways or whatever it is that the business needs. You have the tools at your disposal to do that. You know, it's a hard mental leap from we're so used to this stateful worldview where everything is now to be able to do this replay and it's really kind of like a superpower. Traditional migrations, one of the biggest sources of the stress for traditional migrations is because they're irreversible in many cases. And doing it this way, this Matterbeam style migration, becomes much calmer because so many more things are reversible, so many more things you can reason about, you can see what's happening. So once you have data flowing through a fact stream like this, once you've separated the truth of the business from the systems that consume it, you kind of unlock all these other capabilities that aren't just possible with traditional architectures. Um, you're no longer tied to one system schema or API or performance hits or whatever. You're no longer copying data through a chain of brittle pipelines. You have the source of truth and a timeline in one place. And it means you can rebuild other systems in parallel off of this. So you can say, take this ERP data and reshape it and denormalize it for analytics or an event stream for a real-time application or, you know, things like AI become way easier because you can have this clean, reliable way to replay data and do, vectorization or whatever you need to at that point as well. And as the business evolves, you can evolve with it. You can take new systems that come online, new things, and hydrate them from the same view. This is sort of like where you start to realize the migration was actually the least interesting part of what you just did. Now you have this data that you can now reuse for everything else in a similar style, right? I want to create a product view on a relational, transactional database. You can do it. I want to do something else with it. You can do it, right? Once the, this once you've decoupled this source from all of these destinations, so many things become easier and you can move just way faster. And not just in migrations, but in lots of other ways. So, um, this isn't just talk. I mean, one of our biggest customers, Broadloom, kind of this is what happened. And it was funny because they had planned they had a legacy ERP system. It was literally written in COBOL, which is how old this ERP system was. They had done the one, two, three steps. They had built, done the whiteboarding, all of that. And they came to this conclusion that it was going to be a 2-year big bang sort of effort. And they eventually said it was just too risky. So they started coming up with all these workarounds and things, and they decided not to do it. And when they first started using Matterbeam, their first use case wasn't even the migration. What they were going to do was take this ERP data and take slices of it, like, say, the catalog information, and feed it into another database to run a report on. And it was then when they sort of had this awakening. They're like, well, wait a minute. If we can take these little slices of this ERP system and use it for reporting here and over here, we could actually start to move these things into the new ERP system that we were, designing before they decided to abandon it, and start to move screens like their customer screens over into these new views. And so they were getting value of this ERP migration in weeks or months instead of a 2 year big bang. And so they were able to iterate and move more and more functionality off of this old legacy ERP system into this new world. Um, they've since used it for lots of other things, but that was just this sort of big aha moment of like just how much easier that migration was when they approached it from this perspective. So I'm almost out of slides here. Went faster than I intended. I like this quote. This is Fred Brooks, who the author of the Mythical Man Month. This is sort of the like think about data first, not systems, not code. Think of the data first. Show me your flow charts and I'll be confused. But if I can see your tables, if I can see your data structures, it'll be obvious what you're trying to do. And so moving us more into this data centric, data as prime instead of secondary or afterthought. All right. Yeah. If you want to learn more about how to migrate in this way, if you want a demo of Matterbeam, doing some of these things, or if you have any questions at all, feel free to email me. This is, again, like I said, to put the email back up on the slide at the end. And thank you so much.